Hello everyone, this is a question from Codeforces around 641 and in this video I will be explaining the solution of it. Before jumping into the solution, let me first explain the question to you. So in the question, you will be given an array and you have to find the length of the longest beautiful subsequence of this array. And for a subsequence to be beautiful, there are two criteria given in the question. First criteria says that the subsequence that you select should be strictly increasing. So here I have taken example of three subsequence, and as you can directly see, the third subsequence is not strictly increasing. So we can directly discard this subsequence. This subsequence can't be beautiful. Now the second criteria says that the subsequence you select, first of all write the index of its element from the original array. So for this subsequence, the index of the element will be 1 and the third element is present in the fourth index, so its index will be 4, and the ninth element is present in the seventh index of original array, so here I will write 7. Similarly, for this subsequence, the index will be 1, 3 and 6. Now the second criteria says that the index of the previous element should be the factor of next element. So here, as you can see, 1 is a factor of 4, but 4 is not the factor of 7. So we can't consider this subsequence to be beautiful. And for this subsequence, 1 is a factor of 3 and 3 is also the factor of 6. So here index of all the previous element is the factor of index of next element. So we can consider this subsequence to be beautiful as it is following with the criteria. First of all of its elements are strictly increasing, and it is also following the second criteria, which is index of previous element is the factor of index of next element. So and in this manner you have to first figure out all the beautiful subsequence, then you have to print the length of the longest possible such beautiful subsequence. Now let's start the solution part. So for this question I will be using a 1D DP approach, and the ith element of this DP represent the length of the longest beautiful subsequence from first to ith index, including the ith element. Now let me take you through an example, and I think after going through this example you will be better able to comprehend this statement. So this is the example we will go through. First of all, I have initialized our DP array with all elements set to 1, because in the question it is given that any subsequence with just all element can always be considered beautiful. So with the use of any one of these AI ith element, we can always form a subsequence like this, and it will have a length 1. So I have initialized our DP array with all elements set to 1. Now let's iterate through each of the index one by one and update our DP array. So when we are in the first index, our DP array is currently suggesting that we can form a beautiful subsequence of length 1. Obviously, this beautiful subsequence should have a element 1 here, because the ith element should be included in the subsequence. Now I am asking you, what are the next element that we can choose from here, which we can put in this smaller beautiful subsequence to make a even larger beautiful subsequence. So whatever the element that we choose from here, its index should be multiple of 1. Since it is 1, so we can choose any of these elements. Also, the element that we choose should be greater than 1, strictly greater than 1. 4 is greater than 1, 2 is greater than 1. In fact, every one of these elements is greater than 1. So we can choose any one of these elements to form a new beautiful subsequence whose length is greater than 1. So when we will choose this second element, we will have a subsequence like this 1 4, which is beautiful. Here we will have beautiful subsequence like 1 2, then 1 3, and so on. So we can update now our DP array with 2 here, because now we are seeing that we can form a new beautiful subsequence of length 2 with the use of these elements. Now let's come to second index. When we are in the second index, our DP array is suggesting that the max beautiful subsequence that we can form has length 2. Obviously, this last element should be here, so I'm writing 4. And since only one element is before this second element, we can always write 1 here. So this is the max length beautiful subsequence which we can form by using these two elements. Now I am asking you, what are the next element from here which we can put after this subsequence to form a beautiful subsequence? First of all, whatever the element that we choose should have an index multiple of 2 because this last element has index 2. So we can choose either this element or this element. Also, the element that we choose should be greater than 4 because this last element is 4. Since 3 is not greater than 4 and 4 is also not greater than 4, so we can't update any of the next element of DP. Now let's go to next index. When we are in the third index, our DP array is here suggesting that we can form a max subsequence of length 2. Obviously, the last element should be 2. And before that, we have only one option. We can't put 4 here because previous element can't be greater than next element. So we have only one choice here. We can put 1 here. Now again, what are the next element that we can put after this subsequence? Since this last element has index 3, the next element that we can put can only be this index. And since the sixth element is 4, which is greater than 2, we can put a 4 here and form a new beautiful subsequence whose length is 3. So now here I am updating this sixth element. Let me write down the index for our DP array as well. 1, 2, 3, 4, 5, 6, 7. Now, when we are in the third index, we see that we can put this sixth element in our beautiful subsequence and form a bigger beautiful subsequence. So here I am updating the sixth element of my DP to be 3. Let's jump to next index. Here we are in fourth index. Our DP array is suggesting that we can form a max subsequence of length 2. Last element should be 3. And before that, we can either put 2 or 1. No matter what we put, both of these options are valid. Since the last element has the index 4, what are the next element that we can put after this subsequence? Should have an index either 8 or 16. I mean multiple of 4. So the next index that we choose can have index either 8, 12 or 16. But since our array has max length of 7, we don't have any choice for 8 or 12th index. So there is no valid element that we can put after this subsequence to form a longer beautiful subsequence. So when we are in the fourth index, we have no possibility of updating our DP array further. Similarly, when we will be in the fifth index, we can choose a next element which can have an index 10. But since our DP array has max length of 7, there is no valid choice available. And similarly for all the next element, we don't have any valid choice. So this is the final DP array that we will get after all the updation. And now as you can see, the max element in our DP is this sixth element, which is 3. So this will be our answer. This sixth element of DP suggesting that with the use of this sixth element in our original array, we can form a max length beautiful subsequence of length 3, which will look like it will first have 3 elements and the last element should be 4. And before that, there will be some element from the array, which will eventually form a beautiful subsequence of length 3. So this will be our answer. summing up everything that we have discussed, for the ith index, we will go to all of its multiple, like that 2i index, 3i index, 4i, up to ki such that ki less than n. And then, let's suppose for that 2i index, we will check if element at that 2i index is greater than element at the ith index. And if this condition is followed, then we will update our DP array like this. Now let's see the time complexity of our solution. So for the ith index, we were going through all of its multiple. So when we are in the first index, we will iterate through each element of our array. And when we are in the second index, we will go to the index 4, 6, 8, and so on. So when we are in the second index, we are going next to half of the element of our array. Similarly, when we are in the third index, we will iterate through 1/3 of the element of our array. Similarly, we will do until we reach n/2 index, because after that index, multiple of that particular index will start lying greater than the size of our array. So summing up all this, we have n plus n/2 plus n/3 until 1, and the approximate sum of this series comes out to be n log n. So the time complexity of our solution is big O of n log n.